I will give an example on fuzzy control systems. So now let's consider how to solve set problems, traditional set problems in Matlab. A set is a collection of objects, and each object is defined as a member of the set. So if all the members can be listed, we will call this set a special one, an enumerable set, because we can enumerate all the members in the set. There are some examples. For instance, we have a set which consists of neutral numbers which does not exceed 10. So this is a set we can list all the elements in the set. And also, we have another example, the prime numbers less than 1,000. We have another set. We can list all the elements in the set. However, for this set, since not all the elements can be listed in a certain way, we can always have to use the infinitives. So this one is not an enumerable set. And this set of problems cannot be solved easily with the use of Matlab. So we here concentrate on solving enumerable set problems in Matlab. An enumerable set can be represented by vectors or cell arrays. And here is an example. Suppose we want to represent a set of elements like this, then we can define a vector for A, and A is then expression for this set. And it should be noted that there are repeated numbers in the set, so it is a likely extension to the traditional set theory. So we can use this vector to represent an enumerable set. Also, we can use cells. We can use curved brackets to include all the elements. And in this way, we can also denote a set. We can use either of the two ways to denote a set. And the element of set can also be composed by strings. So we can also define a set like this. If you have already had a set, then we can perform set operations easily with the Matlab files, with the Matlab functions, for instance. If you want to find the union of two sets B and C, you can call a command like this, and you will get the results. And if you want to get the difference of the two sets, you can use set C. Or you can find the intersection of sets, and so on. In the last command, we will check whether element A is a member of set B. If it is, then the value key will be 1. If it is not, then value key will be 0. And small a here can also be a subset. But when it is a subset, then we can use this command to check whether A is a subset of B, or whether A is a strict subset of B. We can use these two commands for set operations, which is quite simple, so I will not demonstrate them here. So now we move to another question. Why we need a fuzzy set? In real applications such as control, the knowledge may not always be represented in an exact way. For instance, if you want to express the room temperature control problem, then you may say that if the room temperature is too low, then we will add some more heating. If the room temperature is a little bit cold, then we will just add a little bit heating. So we may have clauses or methods like this. And this kind of method cannot always be expressed in exact way. So in this case, we have to introduce fuzzy sets. I will explain and give ideas the concept of body set later on. And based on body set, we can create a body influence system from which we can implement some of man's knowledge for certain things. And here there is another question. What is more important? The two factors. One is significance of a matter, and the other one is precision of a matter. In our early computation, such as in matrix computation, we concentrated much on precision of the problems. However, in real application, sometimes precision is not everything. We have to introduce another idea which is significant. And here is a cartoon indicating the difference, the relationship between significance and precision. If a very heavy thing drops from very high, from height, then the best thing is to alert the people is by calling something, look out, attention, something like that. Not in the exact way like this. A certain way of math is approaching your head with a certain speed. That is not useful. So for some applications in real world, they may prefer to use the significance rather than precision. So we need to introduce the idea of body set. Before we introduce the idea of body set, let's review what is a classical set. As I already remind you something like this. In classical sets, suppose there is a set here and there is an element here. So the element and the set, between them there's only two possibilities. One is A is a member of set A. The other possibility is A is not a member of set A. So this set is called grid set. So when small a equals to capital A, the set A, the relationship then is denoted by 1. Otherwise it is denoted by 0. So there's only two possibilities. One is 1, the other one is 0. However, as denoted by Professor Clark in 1965, for certain problems, the membership relationship 1 and 0 is not enough. For instance, if one wants to describe the term old, if you are using a classical set, then you have to set a very exact age here, for instance, 60 years of age. So the curve should be something like this. If a person is less than 60 years, he will not be classified as set A. If he is 60 years old or even older, then he belongs to set A. So this is what classical set means. However, you may find that the other problems. If one person who the next day will be his 16th birthday, so he will not be graded in set A. He is still in the set. So sometimes this kind of phenomenon may not be very fair. Another person who is 1 day older than him may be classified in set A. So that introduced the idea that to describe this kind of thing, he introduced a curve like this, which is called